In the world of construction, understanding the materials we use is crucial. One such material is aggregate, the granular foundation of structures like roads and buildings. Aggregate's density, a measure of its compactness, plays a pivotal role in determining the strength and durability of these structures. Imagine building a house on sand versus solid ground. The difference in stability is clear. Similarly, the density of aggregate significantly impacts the performance of construction materials. This essay delves into the concept of aggregate density, exploring its importance and practical implications in the construction industry. From the foundation to the roof, aggregate's density influences every aspect of a building's lifespan. By understanding this fundamental property, we can make informed decisions about material selection and construction techniques, ultimately leading to safer and more resilient structures. Aggregate density, simply put, tells us how much aggregate material can fit within a specific space. It is typically measured in kilograms per cubic meter, indicating the mass of aggregate present in a 1 meter cube. This measurement is crucial because it directly relates to the aggregate's ability to bind with other materials and withstand external forces. Think of a bag of flour. A loosely packed bag will have a lower density compared to a tightly packed one, even though they contain the same amount of flour. Similarly, aggregates with different densities will pack differently, affecting the overall strength and stability of the final construction material. Understanding aggregate density is not just about numbers. It's about understanding the fundamental nature of the material itself. This understanding allows us to predict how the aggregate will behave in different construction scenarios, ensuring optimal performance and longevity of the structures we build. The density of aggregate profoundly impacts construction, influencing strength, workability, and durability. Higher density aggregates result in stronger concrete. This strength translates to structures that withstand greater loads. Workability refers to the ease of mixing, transporting, and pouring. Aggregate density determines the right consistency. Durability is influenced by aggregate density, affecting water absorption and resistance to damage. Denser aggregates lead to longer-lasting structures. Section 4. Exploring bulk density and relative density. Within the realm of aggregate density, two key concepts emerge: bulk density and relative density. Bulk density, as the name suggests, considers the aggregate's overall volume, including the spaces between particles, or voids. It represents the mass of aggregate per unit volume, including voids, and is a crucial parameter in concrete mix design. Relative density, also known as specific gravity, takes a different approach. It compares the density of the aggregate to the density of water. This dimensionless quantity provides valuable insights into the aggregate's porosity and its potential for water absorption. A higher relative density indicates a less porous aggregate, which is generally desirable for durable construction. Understanding the distinction between bulk density and relative density is essential for selecting the right aggregate for specific construction applications. While bulk density helps determine the overall volume and weight of the aggregate required, relative density provides insights into its durability and long-term performance. Section 5. Factors influencing aggregate density. The density of aggregate varies based on the type of rock or mineral, particle size and shape, and the degree of compaction. Igneous rocks yield denser aggregates compared to sedimentary rocks. Smaller angular particles pack tightly, increasing density. Larger rounded particles create more voids, lowering density. Compaction reduces voids, increasing density. Section 6. Practical applications and environmental considerations. Aggregate density impacts construction projects significantly. In concrete mix design, it influences strength, workability, and durability. It also plays a vital role in road construction and foundation design. Understanding aggregate density helps design load-bearing structures. Consider the environmental impact of aggregate extraction. Promote sustainable practices like using recycled aggregates. Balance infrastructure needs with responsible resource management.